Hello friend, in today's video lecture we discuss endothermic and exothermic process or reaction. Endo mean inside and exo mean outside. Possible we discuss endothermic, the process in which heat is absorbed from surrounding or environment to the system is called endothermic process. That process in which heat is required to supply the system, yes, is called endothermic process. I will show a little bit. Let's suppose this is my system and all is surrounding. In endothermic process, heat moves from surrounding to the system. Heat is moving from surrounding to the system. Yes. So the system temperature is now this is heat and it's moving from surrounding to the system. Yes. Now we show some example of endothermic process. Let's suppose boiling and melting are the example of endothermic process. And melting and boiling we gave the heat and while in condensation or freezing, heat is evolved from the system to the surrounding. Now, as what is endothermic? The process in which heat is absorbed from environment to the system is called. Let's suppose this is environment and this is my system. Heat is moves toward the system in endothermic process. Then delta H is taken as positive because we give the heat. Yes, delta H is taken as positive. Now what is exothermic process? Exothermic mean outside. That process, the process in which heat leave, in which heat are evolved is called exothermic. I will show some example of exothermic also. Condensation and other process is freezing or example of exothermic process. Let's suppose this is my system and this is environment. In this process, heat leaves the system and goes toward the environment. While in case of endothermic process, heat leaves the environment and goes to the system. Both are opposite to each other. While in this process, heat leaves the system and goes to the environment. So the environment temperature become increase, while in this case environment temperature decrease, but the system temperature increase. Yes, understand? Now I will show some example and also say that it is endothermic or exothermic. I will show. This is melting. In melting case, let's suppose this is solid water. This is solid water, and when we give some temperature to the solid water, it goes to liquid state. Yes, in this case temperature is required. Yes, temperature is absorbed by this and converted into liquid. How much temperature is required? How much heat is required? In endothermic process we take delta H is positive and 6.01 kilojoule heat is required to convert solid into liquid, while this is endothermic. Now boiling is also an example of endothermic. Let's suppose this is liquid, and when we give heat, this convert into gaseous or stream. This convert into heat, but also heat is required, so it is endothermic because we give the heat to this water. Now how much heat is required uh, as endothermic process? Heat is taken as positive because we give heat. Now 88.06 kilojoule heat is required to convert liquid into gaseous. Now we come to exothermic process. In exothermic process, heat leaves the system and goes to the environment. Let's suppose this is gases. This is gaseous state. When they leave the heat goes to environment and they will cool, they convert into liquid state. This In this process heat is evolved, heat goes to surrounding, so it is exothermic process. How much heat is evolved? As we know that in exothermic case delta H is taken as negative, so I will write it uh, 88.0 Kelvin kilojoule. Yes, it is released. I mean that in this process this is evolved, this heat is evolved. Yes. Now the second example is freezing. Let's suppose this is liquid. When it is converted into solid state, so heat is released, heat is evolved because it is exothermic process. So condensation and freezing are exothermic process. How much heat is evolved? 6.01 kilojoule heat is evolved in this process. This is all about endothermic and exothermic process. uh, we also have YouTube channel Muhammad Raza is my YouTube channel. Please like this video, subscribe and share it, and also mention your topic that I will discuss. Okay, thank you.